exercising, just analyzing the work that he did to create these notes through mathematics by back converting into Hebrew. Very interesting. Brilliant, super brilliant, incredible. So I thank Steve Reeves, Mr. Reeves, because I'm going to utilize some of that technique in my work, see if I can incorporate some of that healing, that divine healing into some of the work that I do. So thank you very much. We have another speaker coming to the stage, and I actually hope that he's in here. I think I can see him. Yes, I see him there. Great. Let me introduce him. I want to make sure. From up here, it's bright, but out there, it's dark. Okay. Todd Ovakaitys. I hope I pronounced that right. Dr. Todd was the first in his class in his high school and at Northwestern University, and was accepted after 2 years of college to the premier program at St. Johns Hopkins Medical School. He then did further training at Georgetown in internal medicine and pulmonary and intensive care medicine. He has become the leader in laser biophysics research and has developed a stem cell protocol that has reversed biological age at the DNA level more than any other method in medical history. He's my new friend. Me and Dr. Todd about to hang out later. Me and him are going to become real good friends. He has become a leader in laser biophysics research and has developed the stem cell protocol. I had to read that again. It's just too incredible. I mean, this is really cutting edge stuff. I didn't know that before I got here. I'm really impressed. He has been granted multiple patents in stem cells, nutraceuticals, pharmaceuticals, and even agriculture. He also composes chorale and instrumental symphonic pieces, and the transcendental choirs he has created and produced all around the world with up to 900 plus choristers rejuvenate the body while immensely boosting personal vibration and awareness states. The combination of the biomedical and esoteric reflects his passion for the full exploration of expansion of the human potential. Please welcome Dr. Todd.
We'll be hanging out later. Well, that's a lot to live up to. A great pleasure and honor to be with all of you. And it's really exciting, actually, that we can actually gather in one place again. It's just been too long. And maybe I could ask someone to move the instrument, otherwise I might just sit down and invent how to play. And I'm sure the last performer was much better at it than I would be. So, what I'm going to be speaking about echoes the intention that Richard had for this evening, which was going to be giving you a type of vibrational expansion to begin this weekend of adventure of consciousness. And I'm going to address some and even have you sing later, so get your voices ready. Because you'll all sound better than you can imagine, this kind of singing. But I'm also talking about technologies of life. So today's title is Enhancing the Human Potential Through Light and Sound Technology. And even if you've heard me speak before, how many of you have heard me speak before? Some of you, very cool. Well, there's some new surprises for everyone, even you. We work with both light and sound because what you can do with sound, you can do with light, and vice versa. Huh. Oh, okay. They're adjusting my clock here, and it looks like I have to deliver this presentation in about 4 minutes. And if I do, I talk really, really fast. It's like a quantum download. Okay, I'll let them figure that out, and I'll just do my thing. So this amazing doctor who I first met when I moved to California, Jeffrey Thompson, and he discovered that light and sound have a specific relationship, and he created software you could translate one into the other. And he was a chiropractor, and would find that there can be one vertebra out of place, and there would be secondary and even tertiary misalignments. And he found you could align everything just by playing the note of the vertebra most out of place. Really just vibrate it all into balance. And if that wasn't cool enough, if you just shined the light that was the octave reflection of that frequency, it also adjusted the spine. And he's done cool things like getting the sounds from space, that you can basically adjust the engineering of it and literally hear natural sounds from space. So we're going to start the discussion with technologies of light, and then finish with having you get up and sing. Are you ready for that? And if I move the instrument, you want to inadvertently knock it over. Right up. Maybe I can be a mover too. All right, wonderful. So, I began studying lasers when I was 8, and could tell you at that age that laser stood for light amplification by stimulated emission of radiation. And it's really super cool stuff how that works. And without going into the details, it's a way that you create a cascade of photons that are in phase with each other. So as you see in this first line, the waves line up, and they add up to an amplified wave. This gives lasers the property of coherence. So you can literally shine a point of light from here to the moon with a laser. Now, our invention, which is creating that vector zone energy field, there's a vector zone electromagnetic field that J.J. Hurtak wrote about in the Keys of Enoch, is done like this. It's an invention we've created that allows us to adjust the wavelengths of each of the laser beams. Well, to be more precise, we adjust the pathway of each photon through a medium so we can combine two waves exactly out of phase with a holographic address. And this was idealized by me, but invented by a colleague of mine in Scotland named Scott Strachan, an uber genius. I think worked in Maxwell's lab, and for those of you who know physics, Maxwell's equations govern the way we understand electromagnetics. And you can see if we combine the waves exactly out of phase, peaks to valleys and valleys to peaks, we get a sum-zero wave, which means there's no net electromagnetic field. And based on atomic architecture, because there's no net field, we expect it not to interact with electrons. If it interacts at all, it's with the atomic nucleus. And since the nucleus is only 1/100,000th the diameter of the atom, in theory this will go 100,000 times more deeply through a medium than ordinary laser. And that's relevant because you'll see later how we can send a signal through the body that sings the songs of stem cells in life. Now, the really weird, super cool physics is that another way of representing these waves is two waves exactly in phase but going in opposite directions. And the wave going to the right, even according to conventional physics, is not only felt to be going forward in space, it is going forward in time. The wave going in the opposite direction, most interestingly, is not just going backwards in space. Even conventional physics would say it is going backwards in time. So this is the first ever stable, efficient engineering of time reverse light. And metaphorically, if you charge a system with enough time reverse light, the simplistic understanding would be like literally running the VCR backwards. So a disease would be run backwards. Aging would be run backwards. That's not a bad place to start. Now, what's also interesting is that as a wave of light goes through space, it also goes through what's called a polarization cycle. And in one complete sine wave, you have a complete spiral of that. So what we've created is a spiral, counter-spiral of light, which is exactly the geometry of DNA itself. And the principle of resonance, if geometries are in alignment, then the systems tend to be in resonance. So we've also created a beam that will tend to communicate directly with DNA and tell it what we want it to do. Now this is really cool. This is a mobile, which gives a bit of an idea of what the whole waveform is like. Because there's some residual light, which are these little sparkles in a sea of basically invisible light. And this was created by a famous movie star whose real passion is sacred geometry with curves, who believes that the Platonic solids, who knows about those Platonic solids of five perfect forms? Well, he believes that nature doesn't create straight lines. And the true Platonic solids, the sides are curved. They still have the same characteristics, same angles, same faces, and all things are identical except there is a curvature. And when he puts these structures together, it looks like living forms. So I think he's actually right, that the natural Platonic solids are curved. So let's see. Who was Tony Stark's friend in Iron Man? Well, I know he was his own friend. Who said, did you have fun in the fun bee? Terrence Howard. Thanks for helping with that. So this is Terrence Howard's passion. He's a movie star, which gives him the resources to pursue making these models by hand. So we had an aha moment, an incredible experiment. I had a friend of mine at the NIH who was a specialist in bone marrow transplantation, but one time had been my lowly medical intern. And our very first experiment was to pass this new kind of energy through a beam, through a flask that had stem cell-like cells suspended. And this was just literally like throwing it up against the wall, because we thought there could be amplification cascades in cells that would tell us something. And what we found when we did this for varying lengths of time, from 5 to 60 minutes, is that 24 hours later, the cells did something extraordinary, which is they lined up in a coherent column of cells where the beam had been. Instead of 8 to 16 cells clumping together, as these cells would typically do naturally, my colleague said that she estimated 1 to 2 million cells that were organizing. And as you'll hear later, this overcomes one of the biggest limitations of stem cell therapy. So a stem cell is basically a cell that can divide into one of two things. It can either remain in the stem cell pool, or it can go out and replace a cell that's been damaged or been destroyed. And the challenge with stem cell therapy and understanding is that there's a whole hierarchy of stem cells. Stem cells that go all the way from pluripotential, which means they can make all the types of cells within the germ layers, or basically any type of cell, to cells that are germ layer committed, to cells that can only make one type of thing. So stem cells is not one thing, it's many things. And this laser technology basically created a whole new vista for stem cell therapy for any type of stem cell. Because wherever we point the beam, because it goes so deeply through the body, the part that is vector sum zero probably goes all the way from front to back. And I suspect that's true because I've actually shown the laser on someone's head through their brain, and then to another person and another and another, and all 4 people felt it in their brains. What's interesting, if you just shine the laser, they feel the energy, but if you shine it to someone's brain, they actually feel the modulation of their brain waves too. So who knows, it could become a data transfer like Neo and Trinity in the Matrix, where I know Kung Fu! And she goes, I can fly a helicopter now, in all about 20 seconds. The other thing that's relevant is that we measured the molecular chemistry and found we were actually increasing the production of what are called cell adhesion molecules, and these are what the cells need to stick to each other. And cell adhesion is responsible for cell-to-cell communication, which allows the cells in the tissue to tell the stem cells what types of cells the body needs in that particular organ or tissue. Now, typical stem cell therapy often requires 3 to 6 weeks to see a result. Whereas with the method we've been using, we often see improvement in 24 hours, and in a few cases I'll show you, in an hour or less. So, our most significant clinical trial to date, where we treated all the patients the same day and followed over time, was in the area of severe heart failure. And basically, a normal heart comes out about 50% of the blood with each beat. If it's less than that, it's considered mild, less than 40% is moderate, less than 30% is severe. And once the ejection fraction gets into that range, the likelihood of surviving 1 year is only about 30%. Our comparison in the study was a meta-analysis that combines many published studies where the cells were given straight into the coronary arteries, right into the heart. And the result of that was about an 8% improvement in function after 6 months. Our method instead was giving the cells IV, not directly into the heart, which is much safer, clearly, much less invasive as well. And after we gave the cells IV, we did laser guidance, which was simply literally painting the projection of the heart 5 minutes from the front and 5 minutes from the left lateral side. And because I trained in pulmonary medicine and have seen so many chest x-rays, I know exactly where the heart is three-dimensionally in the chest. What was remarkable was that instead of an 8% improvement in 6 months, we already saw a 14% improvement in just 3 days. And it didn't stop there. So these are the results, and every single data point from 3 days to 90 days was statistically significant. And we found that after 1 month, the average improvement was 25%, 2 months, 37%, and after 3 months, it hit 50%, where it basically plateaued. So we saw continuous improvement for 3 months. And our results were essentially 6 times better than the previously reported results for using stem cells for heart failure. You gotta like that. What's also interesting is that half of the subjects improved enough to be considered off of the heart transplant list. And 20% improved almost to normal. Since then, we've had 2 cases outside of the study that only had a 25% ejection fraction, severe heart failure, and after just 1 treatment improved to normal at 50 to 55%, which is certainly a lot easier than getting a heart transplant. And this was published recently in a peer-reviewed journal. What was also relevant was the survival data. And as I mentioned, these patients whose average ejection fraction was only 21%, not just severe heart failure, but severe end-stage heart failure, all heart transplant candidates, that instead of the expected 30% survival in 1 year, we saw 80% survival after 6 years. And what's interesting, the only 2 subjects that didn't survive were the ones that had the lowest response. Our minimum response was a 15% improvement, but our biggest response was a 115% improvement. And we've also learned that if people have a lower response, if we do repeated treatments, treatments, we can stepwise increase ejection fraction. Even those two patients, if they had more treatments, would probably have survived, at least certainly would have been more likely to survive. We have a good test case of that. One of our patients who was treated the same day as the others is the Archbishop of Armenia. He's a war hero, he's beloved of the country. His ejection fraction is 18%. They're looking for a heart for him to be transplanted. And we've done about one treatment per year. And his last measurement was 39%, pushing up almost into the normal range. And it's really remarkable because he generally smokes both before and after the procedure. And he drinks as well. But he's Armenian, give him some slack. So, we worked with various types of stem cells in the early days, primarily stem cells from cord blood, which has the advantage that the cells are really young, but the disadvantage that unless they're your own, they're generally not a perfect match for you. So our method now only requires drawing 6 tubes of blood for age reversal, and a few more if we're going to actually inject locally, either your face to make it pretty, or your hair, your scalp to grow hair, which we've done actually pretty effectively, or into the private parts for lifestyle enhancement, or into the joints. We've had some really incredible results there. So it's only 6 to 8 or 10 tubes of blood, 10 cc's each. Not that much more than you would get if someone was doing fairly extensive blood work just for clinical labs. And then our method is to separate out the red and white cells that we don't need. So we create a concentrated specimen that has platelets, plasma with its growth factors, and a dormant class of stem cell, which is really, really magical. Now, the next slide talks about these cells, and it has a long medical name, which is VSPL, which stands for very small embryonic-like stem cells. Now, what's important is that they are embryonic-like, but not truly embryonic. While embryonic stem cells are powerful, they are prone to form benign tumors called teratomas. And those of you who are medical know that a teratoma can be a cantaloupe-sized hairball with skin and teeth and nails. So like Rosanna Dana, you sound like a really attractive guy. So nobody, I think, wants an apple or orange or grapefruit or cantaloupe-sized hairball with skin and teeth and nails and bones in it. However, just past embryonic, which is what these cells are, they're called pluripotential, which means that they're so early in the process that they can make and replace any type of cell in the body. It's also relevant that they're very small, typically only 1 to 2 microns. Now, there's a lot of work done with something called MSCs, or mesenchymal stem cells, that are from fat or bone marrow, but their average diameter is 12 to 30 microns, or the range anyway. And that's important because if you give them IV, the capillaries in the lung are only 6 microns. So those other types of bigger stem cells, they're really good for getting cells to the lung if that's the purpose, but that's where they get stopped. Whereas these cells are small enough to go to the lung and go everywhere in the body from head to toe, even across the blood-brain barrier, as you'll see. Now, what's crazy cool about these cells, and I really consider it, in essence, a gift from God, that for unknown reasons, at around the time we're born, they go into hibernation. They're like sleeping beauty. They're dormant. They're metabolically inactive. If you do a type of stain that tests for whether cells are alive, they have so little metabolic energy that the dye stains them, and we would generally say, well, those cells are dead, But if we stimulate them into activity, then they become active and they can pump it out and look alive. What's cool about that is because they're not dividing, they're not aging. As you know, when cells divide, the ends of chromosomes called telomeres get shorter and shorter. When they get too short, the cells can't divide anymore. And it's been shown that these cells retain newborn caliber telomeres throughout life. So it could well be the case that even if you're 110, these cells are functionally newborn. And we've had very good results even with people in their 90s with these cells. So it suggests that unlike other types of stem cells, which age and become much less potent as we get older, these cells retain high potency throughout life. It is awesome! And what's really cool is that about a week ago I presented at a meeting called Da Vinci 50, which is a gathering of the world's leading specialists in age reversal medicine. And the day I presented, this article was published. And that was at Sundance. And the real synchronicity is that the first time I presented there on December 10th, 2020, my first article was published. Whenever I go to that place and speak, I get an article published that day. What are the odds of that? So for those who are interested in the deeper science and the origin embryologically of these cells, we have copies actually of all 4 articles that we've published in the past year, for those of you who want to dig into the details. And we don't have enough copies for people to read them and put them back, but if you want, any of you, we can actually send you the PDF file of the full text article. The first article we published was validation that these cells exist, which has been controversial, surprisingly enough. And the 2 remarkable aspects of that first paper were, one, almost immediately after our laser activation process, there were 2.5 times the number of countable cells. And that's faster than cells can divide. So we then published a theoretical quantum biophysics paper, which gave the theory that we're getting just the right levels of energy and frequency to separate out a protein that blocks one of the receptors in these cells. And early stage cells have special proteins on their surface that more differentiated adult cells don't. And one of the big ones is called CXCR4. And there's a protein called EpiX4 that binds to it. And we believe we're literally dissociating that blocking protein so that the antibodies that are used to count the cells can actually measure them. What's also interesting is the cell counts, because other public literature puts the counts at about 1,000 cells per cc, whereas we counted roughly 1 million cells per cc. So just from 6 tubes of blood, there's roughly 50 million newborn caliber stem cells. And we also know when we stimulate them with the laser, by the 4th day they've not only grown in size, but they've also begun to divide and become more numerous.